Hi, and welcome to our new video. In this video, we are going to show you how we designed and built our own 3D printed FPV wing. It has a wingspan of 85 centimeters, and in the version you see here, it weighs 750 grams. It flies with a 3-cell LiPo battery, but can also be flown with 18 650 battery packs. It has a flight controller and a GPS module, which enables some great possibilities like altitude hold, waypoint missions, and autonomous flying. It has a built-in analog FPV video system, so you can fly in first-person view. Due to its sophisticated wing design, it has good flight characteristics, allowing it to fly in challenging environments without a lot of space required. First, we're going to explain our different design versions and their perks, and in the second part of the video, we show you how you can build your own FPV wing. In this video, you can see version number 1. It was partly printed with normal PLA plastic, which made it very heavy, and it required a lot of speed to fly. But it flew, showing us that our project is indeed possible. Version number 2 was a lot lighter than the previous one and actually flew great. But we still weren't happy with the thickness and overall form of the wings. The wings were attached to the fuselage with screws and threaded inserts, which turned out to cause problems in the assembly of the plane. And yeah, we recommend to turn off the gyro for takeoff for obvious reasons. Version 3 had a redesigned thinner wing and a longer nose, which caused some nasty flight characteristics and made it impossible to get the center of gravity right. It was always nose heavy, even with an aft center of gravity. It was clear for us that we had to redesign the wing profile, and to solve the general nose heaviness, we added geometric washout to the wing, which decreases the angle of attack towards the wingtips, therefore producing a nose pitch up momentum in flight. This also improved the stall characteristics of the plane because the wing section closest to the nose has the highest angle of attack, which makes the nose drop first in a stall. On the test flight, we noticed that the aileron to servo control arms were too long, making the plane pitch down by itself. That was a big problem because the remote we used for the flight had no ability to trim, which ended in a stall and a crash. We realized that we need to be able to remove and replace the wings in case of a crash, and for easier transportation, so we designed a wing-to-fuselage attachment system with clips to hold the wings in place. We also had to move the position of the camera from the bottom of the nose to the top to protect the camera against dirt and scratches during the landing. And with that, we were done. We now have a great FPV wing platform, ideal for FPV flying, waypoint missions, or just casually flying around. In our testing, we have measured a top speed of 139 kilometers per hour with a 3-cell 1,500 mAh LiPo battery with a current consumption below 35 amps. The cruise current is between 3 and 6 amps. Now, we are coming to the second part of the video. In this part, we show you how to build and assemble the FPV wing. You don't have to use the same electronics as we did, but we recommend using a similar motor to the one we used. The rest of the system can be configured to your own preferences. You can find all the files necessary to build your own FPV wing linked down in the video description. Here you can see all the printed parts needed for the build. We have already pre-assembled the electronics. You can check out the schematics right here. We begin with mounting the flight controller to the holder with M2 screws. The ESC can be mounted with zip ties. The receiver gets mounted on the bottom of the ESC. In our case, we had to remove the ESC again because we didn't have enough space. Next, we have the motor mount. It's important to make sure the pitch angle is in the right direction, otherwise it can't be mounted to the fuselage. But first, we need to mount the motor to the motor mount with the 4 screws that came with the motor. We highly recommend to put Loctite on the screws because in our testing, the screws loosen themselves after a couple of hours in the air. You can then slide the motor mount into the fuselage. We secure the motor mount with M3 screws. Next, we press the electronics bay into the fuselage and glue it in with super glue. This is the rear fuselage lid. We insert the spring, printed in PLA plastic, and secure it with the screw so the spring bolt is able to move back and forth. Next, we take the GPS module and glue it to the lid with super glue. Be patient to let the glue dry. Next, we glue the 2 fuselage connection pieces by putting glue on them and sliding them into the recess. Then we can slide the front over the connection pieces, which doesn't necessarily need to be glued in place as the wing connectors will later keep it in place. It's better to be able to replace the front after a crash than to thrash the whole fuselage. Next, we take the battery tray with a battery strap and a zip tie for cable management, already attached, and glue it into the recess in the fuselage. This step can be quite tedious, so you will need some patience. Then we insert the PLA spring into the front lid and mount it exactly like the one in the back. Next, we insert the FPV antenna cable into the front lid and secure it with nuts. Then we screw on the antenna. Next, we mount the camera into the nose section. Make sure to mount it the right side up, otherwise you'll have to remove it again. In our case, the camera connector was on the top. On top of the camera, we can mount the VTX on the little platform with screws and nuts. It's important to add spacers between the VTX and the 3D print because otherwise the VTX will melt the plastic. We made our own spacers by stripping some silicone wire insulation. Then we can secure the camera with M2 screws. This step can be quite tedious as there isn't a lot of space for the tool. Then we can connect the antenna cable to the VTX and slide the front in. The front should hold with friction. If it doesn't, we can add some glue. We add the lid, and with that, we are done with the fuselage assembly. Now we are building the wings. First, we have to remove all the support material. Then we can glue the wing mounting clips into the holes. Once the glue is dried, we can slide the wing piece into the fuselage to test the fit. After that, we take the wing middle piece and the winglet and glue them together. Then we insert the servo extension cable into the channel inside the wing. We then take the flexible TPU hinges and glue them to the elevons on one side and to the wing on the other side. Then we take the servo control horn, attach the control arm with a screw and glue it into its slot on the elevon. We repeat the same steps on the other wing. Then we take the servo and screw it to its mounting plate. We can then connect the servo cable to the extension cable and press the servo mounting plate into the wing. We repeat the same steps on the other wing. We can then attach the wings to the fuselage with the TPU clips and connect the servos to the flight controller. We can then attach the front fuselage lid. Now, we connect the flight controller to a PC and configure it with iNav. Once we have finished the configuration, we connect the battery and test if all controls work properly. Once the servos are in the neutral position, we can connect them to the control horns with thin metal wire. If the servo arms are not centered in the neutral position, we can remove the servo screw and center the servo arm. Once everything is connected properly, we can screw the servo mounting plates into the wing. Then we make sure that the battery is not connected so we can mount the propeller. Check the spinning direction of the motor before you mount the propeller. We then mount the propeller to the motor and make sure to tighten the propeller nut properly. If the motor spins in the wrong direction, you can just flip two of the motor wires. Unlike us, please don't test the propeller inside. We highly recommend to put a carbon rod into the wing for rigidity. You could theoretically fly the plane without one, but we don't recommend it, because the forces during the flight are quite strong. The carbon rod should be 39 centimeters or 15.3 inches long. In this demonstration, you can see the plane without and then with a carbon rod in the wing. That was basically the building process of our FPV wing. If you want to build your own FPV wing, you can find all the necessary files linked in the video description. And that was our video. Thank you for watching. Please leave a like and consider subscribing to our channel, and check out our other videos. If you want to see more projects like these, consider supporting us via our Ko-fi page.